Okay, looking at question 12, so we're going to be using our GDC to plot these two different functions. So they've drawn them for you, but that won't give you enough detail. You'll still need to draw your own. So the first part is finding the range of f. So this is my f of x function, it's labelled here, and this is my g of x function. So to find the range of f, that's asking me for the y values. So what are the possible y values of the function? It looks like it's going to keep going on forever, so it's going to be endless, going as high as it can to y. So the only limit is going to be here, which is going to be on your sort of minimum point on the function. So if we go to our GDC, we can plot the graph. So the first function is f of x, which is x to the power of 4 minus 2. And we're trying to find the range of that function, so we need to find what the stationary point or the minimum value is at the bottom. So we're going to go to Menu, Analyze Graph, and we want to find the minimum point. And the minimum point is somewhere around there, and we found it, it's 0 minus 2. So going back to our question paper, we can then write down that the minimum point is 0 minus 2. So the range has got to be bigger than or equal to the y value here, which is minus 2. So the range is that f of x has got to be bigger than or equal to minus 2. And that's for all values of x. The second part, or f of x even, the second part is to write down the x-coordinate of p and the x-coordinate of q. So to do that, we're now going to have to plot the function of q onto our graph. So if we press tab, that allows us to plot a second function, which is x cubed minus 4x squared plus 2x plus 6. And we're going to plot that on the same function. Now, I'm just going to move some of these labels around. It's getting a little bit busy. So Q and P are the intersections at those 2 points. So I'm just going to change this to minus 5 and 5, just so that we can see a little bit more about what's going on. So I'm going to go to Menu, Analyze Graph, and Intersection. And I've got one which is over here, so that's minus 1, 1. This was my minimum point. And I've got a second intersection at Q, which is this side over here, which is 1.52 and then 3.32. So the exam question is asking me to write down the x coordinates only. So it's just the x coordinates. So the x coordinates there are going to be minus 1, and that's equal to the one at P. And so x is equal to minus 1 at P, and x is equal to 1.52, and that's at Q. And we can label on our function here, so minus 1, and 1.52, 3.32. It's always good to label them on because you might need them later. So the part C is to write down the values of the x for which f of x is bigger than g of x. So that, if we look at the GDC here, it's asking where is f of x, the blue graph, bigger than the red graph. So if we look at this, we've got the blue graph is bigger until this point here. Then the blue graph is smaller, the red graph is on top to this point here. And then afterwards, the blue graph is going to be higher. So from our graph, what we can see is that, if I just change colour here, the values of x here, the f graph is bigger, and the values of x along here, the f of x graph is bigger. In the middle, f of x is actually smaller than g of x, so that part's not going to work. So the x values that we just found are going to come in useful to help us here. So the first one is this left-hand side of the graph, so just here, and that part is going to be when x is less than minus 1. And then we've got the right hand side, which is where x is bigger than 1.52. It's not equal to, because at that point the functions are equal to one another, and here we've got the symbol which tells us that f of x has to be bigger and not equal to it.